Chemistry of the Environment, Water for Cambridge IGCSE Chemistry. So Cambridge IGCSE requires knowledge of the chemical tests for water, how to recognise the purity of water, substances that you will find in naturally sourced water, and then how is our everyday supply of drinking water treated. The first chemical test involves anhydrous copper sulfate, which is white. If we add drops of water, do you recall the colour change? You're expected to. It turns blue. The product is hydrated copper sulfate. The formula of hydrated copper sulfate, CuSO4.5H2O. Again, you are expected to recall that. Can you complete the reactant side of that chemical equations? What is on the left-hand side? Stop the class, complete the left-hand side, come back to check. Okay, so we've got CuSO4 on the right-hand side, so we must have CuSO4 on the left. We've got 5H2O, so we must have 5H2O on the left. When we write a formula CuSO4.5H2O, we're saying that there's 5 water molecules trapped in the ionic lattice for every 1 copper sulfate unit. We call those 5 water molecules water of crystallization. The second chemical test involves anhydrous cobalt chloride, but this time a piece of paper impregnated with cobalt chloride. It's blue. If we add drops of water, what colour is produced? You are expected to know this. It's pink. So blue cobalt chloride paper turning pink is a test for water. So we have anhydrous cobalt chloride and water. What's the name of the product? CuCO, and 6H2O. What's the formula of the product? Stop the class, write the name and the formula, restart when you're ready. Okay, so the name of course is hydrated cobalt chloride, just as we had hydrated copper sulfate, we've got hydrated cobalt chloride. The formula, well, we've got to incorporate everything on the left-hand side into the hydrated formula. So COCl2.6H2O. Again, that is in the syllabus to be known. Identifying water by a chemical test tells us nothing about the purity. An easy check for purity is to collect a significant sample and test for the boiling point. The boiling point of pure water is 100 degrees Celsius exactly. It doesn't rise above that figure. The melting point of the ice or of the pure water ice is exactly 0 Celsius. So if we have a substance, we map its temperature as we heat it over time. We get a plateau which tells us the boiling point and an initial plateau which tells us the melting point. If there's 0 and 100, we have pure water. However, the further there is variation from those two temperatures, the more impurity we have. So increasing variation means increasing impurity. On a practical point, distilled water is used in practical chemistry. So how do we get a significant sample of distilled water? Well, we're going to use a condenser, and the process of distillation produces a close to pure sample of water. So we start with water with impurities, we heat it collect the vapour at 100 Celsius, that's the boiling point of pure water. We'll collect a distillate which has few impurities. If we want to be absolutely sure about the purity, we would repeat the process for this distillate. So what are the substances in naturally sourced water? There are 7 substances listed in the syllabus that are found in naturally sourced water. You're expected to recall all 7. So I'm going to go through them. Dissolved oxygen, obvious if you are studying biology. Metal compounds, otherwise known as minerals, dissolved minerals. Harmful microbes, bacteria, viruses. Phosphates from fertilizers, fertilizers is another topic. Sewage. Plastics, a very big concern for environmentalists in recent years. And nitrates from fertilizers. So all 7 of these you are expected to recall. I suggest you might replay this slide, looking at the blank slide to start with. How many can you recall, and just do it a couple of times till you've got all 7. Further to recalling the 7 substances, which of the 7 would be beneficial to the environment? Have a look at the 7, decide which, if any, would be beneficial to the environment. Okay, I'm going to tell you if you are ready. Dissolved oxygen, obviously, aquatic life depends on it. And dissolved metal compounds, that is minerals, also beneficial. Which substances would be potentially harmful to the environment? Have a look at the list. Come back when you've had a think about it. Okay, so I'm going to discuss a bit of a clue in the name, harmful microbes, bound to be potentially harmful. Plastics, again, read up about that. Plastic pollution is a concern. Sewage, apart from anything else, often contains harmful microbes. Phosphates and nitrates from fertilizers. These 3 on the left are associated with deoxygenation of waterways. That damages aquatic life. So the dissolved oxygen, that's a potential benefit to the environment, is removed by concentrations of phosphates, sewage, and nitrates. That process is part of the biology syllabus and not the chemistry. Our final section on water and the environment is the treatment of the water supply. How is it you get water through a tap that is safe to drink? So I'll take you through the 4 stages of water treatment, and then on the next slide I'll give you a small task to check on your learning. So we take water from a reservoir, groundwater, or from a river. The first thing to do is to remove larger objects such as dead fish, foliage, etc., twigs, you name it, floating about. This is called screening. So the first stage is screening, which removes larger items. Then, maybe following the addition of a chemical agent, is sedimentation. That is, solids will sink to the bottom by weight. So the top section will have fewer solids than the bottom section. So if we then drain off the top section, pass it through filter beds for fine filtration. Now that traditionally has been sand, but more recently fine carbon has been used, and that tends to remove colours and odours more effectively. So the fine filtered water is then passed into a tank. Chlorine gas in a pipe is bubbled through it. So chlorine gas bubbles through. Chlorine is a bactericide. It kills harmful microbes. So at the end of it, you get water that's fit for household or industrial use, to drink, to wash, to make beer with. You are expected to recall the 4 processes. So have a look at that. On the next slide, I'm going to ask you a question about them. So here are the 4 processes with a summary word: sedimentation, screening, filtration, chlorination, fine filtration, perhaps using carbon. Could you put them into a suitable order? Which is first, which is last, etc. Stop the class. Come back when you are ready. Okay, so a suitable order would be starting with screening, filtration, then sedimentation, fine filtration, and finally chlorination. So you'll see that sequence expected either in short answer questions or in multiple choice. So well done for finishing. If you want more practice, which I would advise, use your textbook questions first, then find past paper questions. If you haven't come across Physics and Maths Tutor website, I would recommend it. Nothing to do with me, it's just got loads and loads of past papers. For more related chemistry classes, look at the playlist or the links in this video description. If you found this class helpful, please recommend it to a friend. Subscribe for new classes and last-minute exam tips. Please like.